All right. Good afternoon, everyone. Welcome to our May session of Asia SAF Industry Series. Uh, we have our dear experts from ATAG and Axis today. But before we begin, we'd like to kind of update you on what's happening in the world of SAF and here at ASAFA as well. So let's just jump right in. We do have quite a bit going on, but we've grown quite to, let's say, achieve our overall objectives. We really are the first independent nonprofit association formed back in 2024. We are also, let's say, really active with our events, capacity building, and we really activate the market through our activities, as you see later on. Just to remind everyone, we do have overarching aims for the industry, setting together a cross Asia Pacific target of 5% SAF usage through targets or voluntary markets. We also want to bring across small capacity online. As you might know, there are many SAF projects being commissioned as we speak, and we think that by 2030, Asia Pacific, the high ambitious target should be about 8 million tons of SAF so that we can supply Asia as well as the rest of the globe with SAF supply. We're also really technology neutral. We believe from HEFA, ATJ, PTL, Fischer-Tropsch, and newer technologies that are coming our way should be utilized by each country to really facilitate SAF development. We really also think that SAF is really an international marketplace where harmonizing standards and protocols are so important to really ensure liquidity in marketplace. And lastly, our long-term targets are really, apart from capacity building, we really want to build the technical capabilities, and we're striving to do that through our members and partners as we speak. A brief update. Again, we've seen beginning of the year, we kicked off with Singapore Air Show Summit. We've been running webinars every month now. We also have a very insightful Outlook report. If you haven't done so, please download this. And recently, we're holding more members-only closed-door events. Here, this is in Singapore. We had something in Vietnam 3 weeks ago, where really policymakers and industry can closed-door discussions about the future of SAF altogether. We also like to really pleased to announce with the strong support from our members and partners, we're now about 44. We have very interesting names from the whole ecosystem for feedstock collectors, aggregators, producers, technology licensors, pricing agencies, and so forth. We really aim to hit like 50 or 60 within the next few months, and we ask for your support. For those interested to join us, please let us know. You can contact me or Fabrice directly. Some interesting photos. We had our Vietnam event in Da Nang, central Vietnam, 3 weeks ago, where we really had a really strong turnout from the local so-called province, Da Nang province, who gave us strong support, as well as from the central government from Hanoi, with various ministers coming in. Ministry attendees coming in. And we can like to really share with you two big MOUs that we signed. The first one is with IGIP, which is facilitating all biofuel development here in Vietnam. We have a long-term cooperation with MOU to build the SAF capacity here in Vietnam. We are really engaging them on this. Separately, we also have something with DISCC, the SC, which is the Da Nang province. They are actually really active in all things sustainable, green financing, project development. Da Nang is also home to Petro-Vietnam BSR, one of the biggest oil refineries and petrochemical complexes, and they are also really active in SAF. More details can be shared through our newsletters. I think the last few days we've seen something like that. But really, I think SAF for Vietnam is really important initiative that they're pursuing, and we really hope that you will find out a bit more about Vietnam in months and weeks to come. So with that, we also do want to share a bit about the upcoming Bangkok event. This is our second time where we will have the second IPS, and we expect a bigger turnout, and we will have, let's say, 3 days of SAF field activities, looking at how Thailand is probably at the forefront in Southeast Asia to really build more SAF capacities. Excitingly, Banchak is now running the SAF plant. We have a lot of initiatives coming from Thai Airways, even Bangkok Airways, and several airlines, Civil Aviation Authority of Thailand, Department of Alternative Energy, and many Thailand stakeholders are developing new standards to facilitate SAF. Much of this SAF will come from existing feedstocks, the oil base, and the ethanol. So-called supply is ample to supply not only Thailand but the rest of Asia as well for various ATJ SAF projects. We also have a lot of speakers. We're just showing a few of them over here, but we're finalizing the agenda as we speak, and we really look forward to your support for potential sponsorships or exhibitors. Just scan the QR code to find out more over there. Lastly, next week we'll be heading to Canada, to Montreal's ICAO Climate Week. This really important flagship event. We kindly support this through our participation through panels, and we'll be showcasing what we've done so far in ASAFA. We'll be launching our training program come September, and myself and Renee will be there. So feel free to reach out to us, and we'll come back to the event today. Bear with me, so I'll switch over to first speaker, Haldane, who take the stage now. Oh, Haldane, over to you.
Excellent. Thank you very much, Gabriel. It's really, really great to be with everybody today and coming to you from a very warm Geneva in Switzerland, where we're getting proper Asian-like temperatures or Central Asian temperatures here for once, which is fantastic. It's also really great to see so much action taking place in the Asia-Pacific region as well. And so Gabriel and the team have been doing a great job of keeping everybody up to date with what's happening and sort of pushing the agenda forward. That's going to be really important as we head towards a more SAF-centric industry in the future. So I'm going to go through that in my presentation today. But maybe just to start, a quick introduction to the Air Transport Action Group. So our organization was started back in 1990, and it's really here to focus on any of the big global issues that the international aviation industry are facing. And so to start with, it was around capacity, runway capacity, and development of aviation around the world. And for the last 15, 16 years or so, it's really been focused on climate change and how, as an industry, we need to work together to solve the greatest challenge of our lifetime. And of course, it is a real challenge. It's a really difficult thing to do across the entire global economy. Aviation is especially challenging, but I think in many ways, actually, we've got a plan in place as a sector, and we know what we need to do, and there's a huge amount of will to get out there and actually do this work that's needed. So what I'm going to do today is talk through a report that we released back in February, which is our updated Waypoint 2050 report. Waypoint 2050 came out of the idea that as an industry, we have adopted a global goal. In fact, we adopted a goal, a long-term climate goal back in 2008, which was to halve our CO2 emissions below what they were in 2005 levels by 2050. It was ambitious at the time, but of course, since 2008, we've seen the Paris Agreement come through. We've seen all sorts of developments from the Intergovernmental Panel on Climate Change, and particularly their special report on meeting 1.5 degree temperature rise goals across the entire economy, and the importance of net zero as a driver for helping to do that. And so as we were discussing this within the industry back in 2019, 2020 or so, just as COVID was starting to hit, we realized that we needed to focus on updating the goal, seeing whether we could meet that goal that we had since 2008. And then we came to the realization that actually net zero was possible in aviation, very, very challenging, but is possible. And we needed to figure out how we were going to do that. So the first Waypoint 2050 report was to figure out what are the different levers that we need to pull to get to that net zero goal and in what proportions. And then we've updated that 4 years after we initially launched our Waypoint 2050 net zero analysis. And so that was back in February this year, this updated third edition of Waypoint 2050. And it was developed not just by our organization, but actually by nearly 150 experts from across the aviation industry. And you can see on the slide there, a whole range of different organizations played a role in helping us to develop the new Waypoint 2050 analysis from nearly 50 companies across the sector. And importantly, it kind of falls in line with actually analysis that we've seen come out of a whole range of different organizations, including environmental groups and the ICAO reports as well. So that's interesting to see that we've all come to the same general conclusions as to what's the best way to get to our net zero goal. And why net zero is still important, because obviously there's a bit of a discussion at the moment about sustainability in the broader sense, led a little bit by the political situation out of the US, but also by other realizations that net zero is going to be a costly thing for companies across the entire economy. But I think it's still really important that we do focus on net zero, because we do need to align with global climate action and the demand from society, particularly younger generations, for more sustainable mobility. We want to make sure that we can keep people flying in the future, but without the CO2 footprint as much as possible. We also want to encourage joint action, both within the industry, but also outside the sector as well. So how do we get governments to come on board? How do we get the finance community to come on board? And having that global picture, the global objective, really important for that. And I think also an important message coming out of the new report is really to accelerate the scale up, both of things like SAF, but also other technology and operational improvements as well. And we've put a target on there over the next 5 years. We really want to see an acceleration in the policy landscape and also in commitments to improving the efficiency of our network and switching to new types of energy. So I think it's always really important to look back at where we've come from and how that plays out in the future as well. So if we look back to 1990 and where our CO2 emissions have gone in that time frame, it's at the bottom of this chart here. The blue line shows where our CO2 was in 1990, where it is today, and where we need it to be in 2050. The red dotted line shows where we would be in 2050 and today if we were still using the same types of technology and the same operational efficiency that the industry had back in 1990. And that's really to illustrate that we actually have achieved a lot in the last 35 years, that we've actually managed to avoid about 14.6 gigatons of CO2 from being emitted because of our efficiency improvements and because of technology improvements that we already have under our belt, if you like. The blue dotted line shows that if we were to continue using today's level of technology and aircraft and today's level of efficiency across the fleet, but with traffic growth continuing to increase, then we would be at around 2.5 gigatons of CO2 in 2050. So the key challenge for us as an industry is identifying how do we get from that level down to net zero through new types of technology, through improvements in operations and infrastructure, through new types of fuel, and also through market-based measures for dealing with residual emissions. That's the key question and the key challenge that we've got to deal with ourselves. So Waypoint 2050 looks at two illustrative scenarios for how we get there. So scenario 0 here is a baseline. It's what if we don't do anything more than we've done already, and we just keep flying and we keep growing our traffic growth, but we don't really do anything else. How much will we need to offset or deal with using market-based measures? And then scenario 1 and 2 are just illustrations of how we would get to net zero in the best way possible. And so I'll go through each of those now. So you see here, scenario 1 really focuses on SAF deployment. A majority of the emissions reductions come through the use of sustainable aviation fuel. There is some technology improvement, as we would expect, because we don't ever stay static in that sense. So every new generation of aircraft that comes in is about 25% or 20% more fuel efficient than the one it replaces, which is fantastic. We will also put in place efficiency improvements through operational measures, through air traffic management, and through infrastructure measures as well. But there's a limit to what we can do in that space. We'll get onto that in a bit. SAF obviously fills in a big part of that gap. And then at the end a certain amount of market-based measures, of course, starting to shift towards carbon removals from the offsets that we generally use today. So that shows scenario one, really focusing on the SAF deployment. And it shows that we probably need about 430 to 500 million tons of SAF in 2050, depending on the emissions reduction factor or the life cycle assessment of that SAF production, of course. And then scenario two really tries to push the technology side as much as possible. So what we've done here is really try to push ahead on things like hydrogen in the latter years, and we'll get onto the way that these technologies can roll out in a bit. It also recognizes that we actually don't know what the mix will be between SAF and between market-based measures, particularly carbon removals, as we get into the later years, so 2035, 2040, 2050. If carbon removals, particularly things like direct air capture carbon removals, become incredibly cheap, then there will be a decision to be made on a commercial basis between purchasing SAF, particularly things maybe like power to liquid, which might be a little bit more expensive, and carbon removals. And there'll be a commercial or a market decision that decides exactly how that split is. But what this does is it recognizes that we are still going to need SAF in fairly large quantities, and we're also going to need carbon removals to play a role in the future of our decarbonized industry as well. So I'm going to go through a couple of the different elements of our four-pillar approach now, but obviously focus more on SAF given the audience. But on the technology side, we had a whole range of different scenarios that we looked at to figure out what would be realistic, but also a little bit visionary when it comes to the technology side of things. So we did look at things like hydrogen and electric and what's called hybrid approaches. So hybrid electric and a more electrified aircraft, which can improve efficiency, but not necessarily change the energy input and also not necessarily require a wholesale change in the way we think about the system that's been built up as well. So they're fairly realistic scenarios. We have tested this. It's not trying to push technology beyond what is likely to happen. But we also want to make sure that we have a bit of vision in that process as well. So technology is really important for improving the efficiency of the aircraft itself, but obviously operational and infrastructure improvements are really important as well. One of the reasons that they're so important is because we can take those early actions now. We don't have to wait for new technology to be deployed. We don't have to wait for new energy to be deployed. We can actually put in place air traffic management improvements, particularly today. And we should be doing that already. And already there's a lot of progress in that space. One of the challenges there is that as traffic grows, the airspace becomes more congested and less efficient. So even though it looks here as if the three scenarios that we looked at when it came to operational improvements are relatively modest, let's say, 0% or just a few percent. Actually, what that suggests is that because we are reducing the efficiency of the airspace by having more aircraft in the airspace, even a 0% change is an improvement. We're not going to get that by itself. We have to work at that. And so any kind of efficiency improvement that we can get out of the airspace as traffic grows, particularly in those high growth areas, is an improvement. And we're going to have to work at it. It's not just going to happen by itself. So it is really important for us to spend time focusing on that operational efficiency improvement as much as possible. But of course, as we saw in both those scenarios that I showed, actually the biggest area that we do need to work on is sustainable aviation fuel. And we all know the reason why. It's using current aircraft technology. We don't have to change the fueling system. It's really just a drop-in replacement. So it's easy, right? It's not going to be a hard thing to do. Of course, it's very, very hard. Where do we need to go? Okay, so we're going to go from potentially 2 million tons of SAF that were delivered last year up to maybe 20 million tons of SAF in 2030, which I think is relatively achievable. It's not going to be easy to get there, but I think that's relatively achievable. But then my biggest question is, how do we get from that in 2030 out to potentially 500 million tons in 2050 in order to meet some of these goals. That's the biggest challenge. And that's where we really need to be putting in place as much work and emphasis and effort as possible across the industry. So we know that the momentum is building behind SAF. If we look at the number of states that have policies in place, it's really, really impressive actually to see 45 countries now have SAF policy in place, either in law or in the process of getting into law. And of course, a lot of that is in Europe with Refuel EU, but we are seeing it in countries all across the world as well. Most of these are on the demand side measures rather than supply side incentives, although obviously the US very heavily on the supply side incentives. But we do need a mix of those different incentives to make sure that we get there. With a fairly conservative analysis of where those policies are today, and where we expect them potentially to be in 2050, we get to around about 150 million tons of SAF. So that's kind of not doing anything extra than what we've already done or what policy has already done. And obviously there's a huge amount of work to build up the production process to deliver that. But from a policy perspective, that's kind of where we get to. Of course, that falls far short of where we need to get to. And this really illustrates here in the different SAF scenarios that we have as part of the Waypoint 2050 report, the gaps between the F1 scenario, which is right there at the bottom in about 150 million tons, and potentially up to sort of 430, maybe 500 million tons, depending on the emissions reduction factor that's used. But it shows where we do need to really push the right policy incentives forward as well. As I said before, the previous analysis on the last slide of current policies in place is a fairly conservative one. They will be ratcheted up over time, and so we can expect that starting to close the gap as we move forward as well. So of course, a lot of that has been done over the last 10 years or so, really to focus on the climate objectives and reducing CO2 emissions. But there is another incentive that we have to think about our energy supply as an industry, and for governments to think about it as well. And that's being illustrated right now with what we're seeing in the Straits of Hormuz, in the fact that actually when we're thinking about energy, we should be thinking about diversification of energy supply, both in terms of the geography of it, but also the types of input. And this can have other effects, including things like cost, maybe not reductions, but certainly cost balancing over time. So at the moment, we're seeing that about 90% of our fossil fuels come from just 22 countries in the world. And some of them are big countries. So on the map here, it does look like actually quite a lot of the world produces fossil fuels. But in reality, it's a fairly small number of countries. SAF gives an opportunity for many, many more countries to potentially produce SAF or energy for aviation and other modes of transport as well. And that's a real opportunity for jobs and for green growth and for a rebalancing of our energy system in a fairly democratic way. We also have to think about the inputs. So at the moment, 99%, probably a bit over 99% of our energy for aviation comes from fossil fuel, just one input. And of course, we see the price fluctuations that have occurred historically, and then particularly in the last 6 weeks to 2 months around fossil fuels and how that is a grip on our business, if you like. We can shift to a variety of different sources. So there will still be fossil fuel supply for aviation, particularly in 2050. Maybe we can move off it later on, but there will be an opportunity for us to look at different types of SAF. And all of you know very, very well the different types of SAF that could, or the different types of inputs that could come into the SAF system. So that's a real opportunity for us to think about that diversification of supply. And then when it comes to geography as well, this is some analysis that was done for the Waypoint 2050 report, looking at where SAF could potentially come from. It's no surprise there that Asia Pacific could potentially produce some of the largest quantities of SAF if that opportunity was grasped. But it's not just Asia Pacific, it's other parts of the world as well, which does lead to that more diversified energy supply. And of course, the work that the ASAFA team are doing to really promote SAF in Asia Pacific is a really important part of that process. We kind of need to see ASAFA type organizations in various other parts of the world to really push SAF development in Africa and Latin America in particular quite usefully as well. So if you look at how our energy mix can change over time and where we're going to be looking for different types of CO2 reduction technology. This is a matrix that I think a lot of people find quite useful, showing that even though there are some opportunities for electric, potentially for hydrogen fuel cell in particular, and of course the hybrid model in some of the smaller aircraft in the next decade or 2 decades, actually most of our emissions come from medium and long haul. So that's about 75% of our CO2 emissions. And we're going to rely on SAF right out until 2050 for those types of flying. And so that's why SAF is such an important part of the mix, even though it's really important for us to try and experiment at a smaller aircraft and a smaller distance scale with electric and hydrogen. SAF is going to be the key to our decarbonization story. Finally, in our list of 4 pillars, market-based measures, I won't spend too much time on this. I think we all know that there are offsets available today, that CORSIA has been set up as a system to try and ensure that there's a standardized level of offsetting across the world and relating to the growth of international aviation CO2 emissions. There are various emissions trading schemes as well. And so that is an important part of our mix, because we do know that we're probably not going to get to net zero without the use of some type of market-based measures. Of course, it's really important to try and reduce and keep that to a minimum as much as possible. And of course, carbon removals are a key part of that process as well. So one of the other pieces of analysis that we've done in Waypoint 2050, just to figure out how much carbon removals we're going to need in 2050, because we need to start building that market up as well. It's not good enough for us to just think about SAF supply. We also need to think about the supply of carbon removals and making sure that aviation is one of the identified customers for that in the future, and sort of reserving our carbon removals, if you like, as those projects develop. So the key messages coming out of Waypoint 2050 this time, that net zero carbon for aviation in 2050 is an important and ambitious goal. It's still very challenging, but it is within reach. Next 5 years are crucial, and the reason for that is if we are going to develop the SAF supply chain, for example, for 2050, we really need to start that work now. And yes, there is a lot of work that's already ongoing. That's great. We need to see that in more countries around the world, and to really put in place the right policies in the next 5 years to get us on the right starting block to where we need to be in 2050. We need to think ahead of the demand. But it's also this is a collective effort. It's not just aviation industry people that need to be part of this. It's also governments. It's also the finance sector and the energy sector as well. And then, of course, given the current conversation, I think it's really important to just remind people that the scale up of SAF is not just about decarbonization. It's about balancing supply and logistics of supply chain security, but also the cost dynamics of our energy system, as well as creating green energy jobs and economic opportunity in countries all across the world. And so that 5-year window that we talk about, we really need to use that as an opportunity to scale the production of SAF globally to match demand, to reaffirm the support of CORSIA and the development of CORSIA. That's really vital, particularly in the next 10 years or so. And then as CORSIA develops, continuing to support that global system as much as possible. We need to deploy fuel-efficient aircraft faster and into the fleet. And of course, there's some supply chain challenges that have come into the system since COVID. They need to be overcome and really getting those aircraft out into the system. We also need to modernize air traffic management and think about the carbon removal business as we move forward as well. So some key messages there. All of them are available with a whole range of different calls to action in our Waypoint 2050 report. That's available on that website, aviationbenefits.org, and quite a useful read if you're in this space. Of course, this is at a global level. We also need to see similar analysis at regional levels and national levels and by companies as well. So hopefully that was a useful guide to what we've done with Waypoint 2050, and happy to answer any questions or take any comments from anybody.
Thank you for that, Haldane. It's really insightful. A summary of the report. I urge everyone online to take a look at the report. It's really, really good. I think this edition. We also had the chance to run a little poll about net zero. Can we reach net zero 2050? The good news is at least 2/3 in the audience feel it's possible. Maybe, likely, but okay. It's quite optimistic. But I think we also have some questions right now, so I'll just flash on the screen as well. Great presentation, clever thought. Many thanks. However, when looking at future pipeline of SAF available, I think Haldane goes to you, right? Have you accessed the UCO limitations, nascent status of ATJ, commercial launch, filtering out projects pre-FID, time to launch? Maybe you wanna take this question?
Yeah, absolutely. So yeah, absolutely, we did do that. We obviously looked at how much SAF we would need. That was part of the sort of underlying analysis for the whole thing. And the way that we did that was with those 150 experts, we had them in different working groups, and then we pulled everybody together in a workshop in Washington, D.C., where we looked at the different scenarios that we had. We decided which scenarios we would have in our illustrative scenarios, and we put those together. Once we had figured out what our technology pathways were likely to be, what our operational efficiency pathways were likely to be, we then filled in the rest, if you like, with SAF and also market-based measures. So we put an artificial number on how much SAF we would use to replace fossil fuel. So we put it at 90% of our fuel supply would be SAF in 2050, because we needed to have one variable number, or unvariable, if you like. And so the remaining SAF was just a quantity of how much SAF we would require. We then sent that off to the team at ICF, who've been working with us for a while, and they broke that down into where that SAF could come from, based on things like limitations for UCO, for example. And so obviously the HEFA process, and we've got all this in the report, so you can have a look at the numbers. But the HEFA process using used cooking oil has a ceiling. There's a limitation of that. That'll continue out to 2050. It's not going to get any bigger from where we are probably in 2030 or so. But that does remain. We then have alcohol-to-jet. We then have and various other opportunities as well. So we took a fairly conservative approach to this, and there are a whole range of opportunities that we did not include in our initial analysis, but we have included in the report. There's some amazing stuff looking at sewage to fuel, for example, which we haven't included in the main analysis, but it could actually add opportunities to what we've identified there as well. So we did do that sort of underlying analysis. What we haven't done is look specifically at each of the FIDs, look specifically at each of the plants, for example. We do have a fairly good analysis of where we are going to be by 2030. Beyond then, it gets a bit more fuzzy, obviously, for understandable reasons.
All right, I think it's a good time to kind of read the report in detail.
Yeah.
I think another question that stood out from us as well was your slide on this rebalancing about, SAF is really a local story. Perhaps you could mix SAF within your own country, within your own regions, and move away from fossil fuel. Do you have any insights? How has the geopolitical crisis reshaped the conversations?
No, I think it certainly has reshaped the conversation, and I think which is a good thing. We should have probably been thinking about that all along anyway, in reality. But obviously, the fossil fuel system, which has been built up over the last 150 or so years, is incredibly effective. It works very, very well for supplying us with energy. And there's obviously some vested interests at stake there. But in reality, for the global community, it has done an awful lot to help us. It's really lifted millions, billions probably out of poverty. It has enabled the modern world that we live in. And so it's kind of hard to tear ourselves away from that. what we're starting to see actually in the global conversation at the UN level is more and more discussion around the end of fossil fuels and how do we get ourselves off fossil fuels before we have to, before they sort of become a massive challenge from a climate perspective or from a supply perspective. So that conversation is starting to change now, and the last 2 months have really illustrated that properly. So I think that is a really useful way to think about things. We are going to have to think about our energy system in a much more cohesive way than we have been previously. And that just gives us, because we've already got our pathways towards SAF identified, even though we don't know exactly how we're going to get there, we are in a pretty good position of being able to think about the replacement for fossil fuel. And so I think we just need to accelerate that conversation as much as possible.
Yeah, thanks for that. I think on our side, we've been speaking to a lot of people and stakeholders in industry, policymakers as well. I think it's realism is setting in quite a bit, at least here in Southeast Asia, right? Where we're still heavily reliant on crude oil imports. And again, you're building the base with green power coming in for power, solar, wind projects. But the next, again, challenge would be liquid fuels for land, air, and maritime. So I think there's a good conversation to have.
There was some interesting analysis coming out of the International Energy Agency actually about the effect of the Strait of Hormuz closure on energy prices, across the world, and showing that actually those countries that have diversified their energy supply across the board, not just liquid fuels, like Spain, for example, but also like China, have fared better from a impact perspective because they have alternatives to think about. And so that's food for thought for everybody, I think.
Alrighty. No more questions in the chat. Haldane, thank you for the lovely presentation. Let's welcome Jeff, who's joined us from Malaysia. Give me a second. I'll show his slides. And Jeff, over to you.
Okay, very good. Thank you, Gabriel. Thank you, Haldane. That was a very nice presentation. Nice to follow up on you. Obviously, there's lots of progress that needs to be made in terms of SAF consumption, but first SAF production. This is where Axens as a process technology licensor comes in to provide commercially ready technologies for the production of SAF. Today, my presentation is really going to focus on ethanol-to-jet pathway. Whether it's first generation crop-based ethanols or second generation lignocellulosic ethanols. We'll talk about the latter because in this region in Southeast Asia, there's an abundance of biomass feedstock that could be used for production of second generation ethanol and then onto alcohol to jet for SAF production. Let's see. Okay. Just a further introduction to myself. So my name is Jeff Caton. I'm the commercial director for Axens based in Kuala Lumpur. I've been in the region for 6 years, dealing with customers across the oil and gas industry, but also in the domain of renewables. Axens, for those of you that don't know, we are 100% subsidiary of IFPEN, which is the French Petroleum Institute and New Energies, based in France. Our mother company, IFPN, does research and development to develop process technologies, as well as catalysts and adsorbents that go with those process technologies for the production of clean energy, as well as renewables, as well as in the areas of low carbon hydrogen, natural gas purification, carbon capture, plastics recycling, etc. IFPN has been around since post-World War II, so the 1940s, doing that research and development. Axens name was created in 2001 as essentially the marketing vector for those process technologies developed by IFPN. We've been in biotech since the 1990s, where we started with a fatty acid methyl ester technology, and progressively we've moved into other technology pathways for renewables. If you're unfamiliar with the role of a process technology licensor for a project, you can refer to this pinwheel on the right-hand side of the screen. Essentially, we will get involved with a project developer or customer at the very conceptual stages of a project. For SAF, this could be where somebody says, we want to produce SAF, we have X feedstock. What technology pathways could we consider, which would be the most technically viable, economically viable, and we will help them develop that project during the conceptual stage. We'll then move around through technology catalyst selection, process design, where we will complete the basic engineering, and even possibly some of the FEED or EPC work. We also license the technology, which means we own the rights, but we will grant those rights to build, own, operate, and maintain a facility using that technology for the production of SAF. We'll stay involved in the feed EPC stage of a project as a technical advisor, or again, we could conduct the feed and EPC ourselves if we're delivering the unit in modular form. We will provide catalysts for the process, proprietary equipment, and again, potentially modular supply. We provide operator training to the unit engineers, the operators of the plant. This can be classroom-based training, dynamic simulator-based training. And then commissioning and startup, we will have technical services advisors that will come on site from the very beginning of mechanical completion stage through pre-commissioning, commissioning of the plant, through startup, stabilization, and ultimately a process performance test run to make sure that the plant itself is producing the SAF yield capacity with the right utility consumptions, hydrogen consumption that we have guaranteed that the technology would do. And then ongoing, we provide technical services and operation support for the life of that plant for the decades to come. So we consider ourselves as a licensor when we engage with the customer at the conceptual stage of a project. If we go forward, we will essentially be married to that licensee of ours for the life of that operating plant. Okay, next slide. In terms of SAF, where we are active, we actually, Axens, are in a unique position that we have process technology for all of the AS Team certified pathways for SAF production. So starting at the top, we have co-processing technology where we can help our customers through revamped studies of existing assets in refineries to see what potential for co-processing exists. We can provide our catalysts to go in those processes to enable the co-processing, some equipment solutions as well. We then get into our HEFA technology, which is called vegan, which we will use again to process renewable oils and fats. So everything from used cooking oil, animal tallows, non-edible oils, edible oils, through that HEFA process to produce SAF and or renewable diesel. If we move down from the renewable oils and fats into lignocellulosic biomass, we actually have two technology pathways that can be used for the production of SAF. The first one, which we're discussing today in more detail, is the Futurol second generation ethanol technology, plus our Jetanol alcohol-to-jet technology. The second pathway that can be considered for lignocellulosic biomass is our bio-T-fuel technology, which consists of torrefaction of biomass. We torrefy it, make it into essentially a coffee roast. We put it into a gasifier. We produce syngas. We clean that syngas up, and then we go through Fischer-Tropsch and Fischer-Tropsch upgrading. We also have technologies in the area of eSAF with our Carboversia reverse water gas shift technology, as well as Fischer-Tropsch and Fischer-Tropsch upgrading. And then on the newer technology development side, we're getting involved on the methanol to olefins and olefins to jet through our Jetanol technology, which on this slide I recognize we put coming soon, D7566. If those of you who are not familiar, within the last couple of weeks, the methanol to jet pathway has actually come under approval by ASTM. So it is now a certified ASTM pathway. Okay. This slide just shows you a little bit, which I think most people who are familiar with feedstocks that can produce SAF and the production costs associated with that SAF have probably seen this slide or a similar slide. Essentially, it's showing the feedstocks for oil and fats. So again, back to this used cooking oil, animal tallows, Corsia certifiable oils are relatively limited in capacity. So while the production cost via the HEFA pathway is much lower, the actual supply of feedstocks is also limited. What this means is ultimately those feedstocks will come under supply constraints, which will drive the price of those feedstocks up, which will then increase our production costs for that technology pathway. So while today it's the lowest cost of production, that doesn't mean tomorrow when the feedstocks are really limited in supply that it won't become a higher cost producing technology pathway. When you look to the next right, you'll see sugars and cereals. So this would be sugar, molasses, and corn, really geared towards the production of first generation or crop-based ethanol, which can be used in the alcohol-to-jet pathway. So these are much more readily available feedstocks producing ethanol today. That feedstock is available, and we can go through the alcohol-to-jet pathway at a cost of production that is just slightly above the cost of production of the HEFA pathway today. If we move to the next to the right, we start to get into, again, our biomass feedstocks, woody, grassy, agricultural waste feedstocks. And again, we can go through the two pathways of second generation ethanol production, then alcohol to jet, or bio to liquids through our bio-T fuel technology. Those feedstocks are obviously much wider available, especially in the Asia Pacific region. But the cost of production due to the CapEx investment and the cost of aggregation of the feedstock will lead to the higher cost of production using these technology pathways. Then we go further to the right where we have really an abundant, limitless, let's say, amount of feedstock in the eSAF domain. So this would be CO2 either captured from direct air capture or from flue gas emission sources, paired together with renewable electricity coming from solar, wind, hydroelectric, geothermal electricity to produce eSAF. Obviously, the feedstock is widely available because it's sun, wind, or CO2 that exists today. But the CapEx investment associated with this is quite high. Also, the cost of production will be heavily impacted by the renewable electricity costs where you will build the plant. So in areas where renewable electricity cost is at a high amount, eSAF will not be feasible to produce because the cost of production will be so high. However, if you're in a region where renewable electricity can be produced at a low cost, maybe you can take advantage of low-cost solar as an example. eSAF projects can make a lot more sense, but still directionally much higher cost than the other technology pathways. What is driving, of course, for those of you that know, the eSAF will be the sub-mandates that exist today in the EU Refuel EU requirement, which requires a sub amount of eSAF to be making up the entire SAF pool, as well as an eSAF mandate in the UK SAF mandate. So that's what will drive the adoption of eSAF. Okay, so today, again, we're going to focus on Jetanol, our alcohol-to-jet technology, but also Futurol, our second-generation ethanol technology. Again, the Jetanol technology can be used for first-generation, second-generation, or any ethanol source. So we can put that separately, or we can pair it together with our Futurol second-generation ethanol technology. Today, we'll start with second-generation ethanol production. For this, we have our Futurol technology, which again is going to take biomass of various sources. So anything from agricultural residues, forestry residues, energy crops. We're going to take that biomass and we're going to pre-treat it in the first section. The pre-treatment section is essentially going to exist of adding some water to the biomass and then doing a steam explosion to depolymerize or break open the lignin to allow accessibility to the cellulose and hemicellulose contained in that biomass. Once we've done that pre-treatment, a side stream of it will go into our second block where we're going to do our biocatalyst productions, which is our enzymes and our yeast. These will be used for enzymatic conversion and fermentation in the main portion of our process. The bulk of the pre-treated feedstock will come directly into hydrolysis and fermentation, where again, it will go through that enzymatic conversion and fermentation of the sugars to produce our ethanol. And then we will go into product separation, where we will distill, producing the ethanol, as well as our byproducts of CO2, lignin, and then also stillage, which can be used to produce biogas as a byproduct from the process. Futurol has been developed by Axens, our mother company IFPM, as well as a consortium of technology providers. We've demonstrated the scale of this through pre-treatment at 100 tons per day of biomass feedstock in France, and then have a full-scale demonstration plant at 1 ton per day of biomass feedstock that is available for tours at any period of time for technology evaluation. We currently are also engaged in a commercialization of this technology through a Axens invested project called NACR. This is in the south of France. Right now, this project is reaching FID. This says 2025, but it will reach FID in the middle of 2026. The idea here is to take agricultural and forestry residues from the south of France, bring those together, which will exist in a 70-kilometer radius, bring those together to produce 30,000 tons per year of second-generation ethanol, and then the byproducts of biomethane, biogenic CO2, lignin, and lignin. We have decided to invest ourselves in this technology because second-generation ethanol is still not commercially well adopted, and we believe that it will take our own investment in such project to really drive the commercialization and showing to the industry that it is a truly scalable commercial technology. So more to come with an FID in 2026 for this project. Once we have our ethanol, again, could be from second generation ethanol from Futurol, or again, first generation ethanol from corn sugar, we can go into our Jetanol process. This is our alcohol to jet process that is commercially ready. The process consists of 4 steps in total. The first is dehydration, second oligomerization, third hydrogenation, and then fourth fractionation. We'll talk about each of these steps in a little bit more detail. Our technology is commercially ready because it actually consists of process technology sub-bricks that have been demonstrated throughout the refining and petrochemical industry over the last 4+ decades. So in dehydration, we have a current operating plant, commercial operating plant with Sumitomo in Japan. For the oligomerization step, we have well over 100 references, hydrogenation over 700 references, and then fractionation is a simple process that's demonstrated everywhere in the industry. Jetanol, the sub-bricks, as you can see here, dehydration with ATOL technology. This is where we're taking the ethanol and we're dehydrating it, removing the water, and producing an ethylene or an olefin, which is our building block for sustainable aviation fuel. Once we have that ethylene or that 2-carbon building block, we will then go into our oligomerization, which is a 2-step process to click those building blocks together into a long chain hydrocarbon, meeting the kerosene or sustainable aviation fuel range material. We will still be left with a olefinic or a double bond in, so we still need to go through the final step of hydrogenation, where we will saturate that olefin, producing our final SPK, synthetic paraffinic kerosene molecule, in that last step. So you can see here again the development and demonstration of these technologies over the past decades. Some key advantages to the technology bricks. The ATOL technology is developed with a leading catalyst. So it's really it's providing us with 99+% conversion of ethanol to ethylene on each pass with very, very high selectivity towards ethylene. Very limited byproducts, which simplifies the separation scheme of the ATOL technology, leading to lower CapEx and lower operating costs. The catalyst itself that's used in this process is also highly regenerable and very tolerant to impurities. It also can operate in a high water phase, meaning that the ethanol source can be anhydrous or hydrous ethanol. We can take either into the unit with no impact on the process or the process design. The next step of oligomerization, we actually utilize 2 technologies for this process. The first one is our dimersol technology, which is using a homogeneous catalysis or liquid phase catalyst. This technology has been developed by Axens for the dimerization of ethylene and been used in the petrochemical industry for decades. It's also been used in refining for decades. The idea here is that we can dimerize into fuels, such as in refining, or in the instance of petrochemicals, we can dimerize into co-monomers that are used for plastics production. The reason why Axens has developed a homogeneous catalysis for this, which has been a winner of the Nobel Prize under Axens developments, is because this reaction is very highly exothermic and very difficult to control. So with homogeneous catalysis, we're able to access easy heat removal from the process, as well as control precisely the dimerization reaction, getting the dimers that we prefer to have, which increases the overall selectivity of our process. Once we've dimerized from ethylene into butenes, we then go into a further oligomerization step using our polynaphtha technology to then get us into the kerosene range material. And again, this has been used widely in refining industry for decades to produce gasoline, diesel, or jet fuel material. Showing our commercial reference list for our alcohol-to-jet technology, you'll see here that we have references with Gevo. Gevo, in fact, is an alliance partner of ours in the U.S. So our technology is being used together for those 3 Gevo projects that you see there. Idemitsu in Japan was our next award. That project is currently working on FID, hopefully to come either this year or early next year. We have another project under development in Brazil, and then 2 other projects currently under development in the USA. And you can see the capacities for these projects run anywhere from 80 KTA of SAF production all the way up to nearly 500 KTA. Today, as of today, these projects are based on either sugar or corn-based ethanol. One recent press release that you may have seen for our technology is with Praj. In India, we actually have another alliance there where Praj will utilize our alcohol-to-jet technology for production of SAF. Praj went to the extent of taking the technology and building this pilot demonstration plant that you see here, really to be able to test all different ethanol supplied across India through the process to ensure that the SAF specifications can be met through the process. This pilot unit was started up in 2025, and again, has been operating successfully on a variety of different ethanol feedstocks from India. The next slide I want to do is just a quick economic case study on our alcohol-to-jet technology to show the importance or the highest impact of ethanol feedstock costs on the production cost of SAF from the alcohol-to-jet pathway. On this slide, what you'll see is on the left, the reference anhydrous or dry ethanol basis. This could be, as an example, ethanol coming from corn ethanol in the USA. So if we take that as our baseline ethanol feedstock cost, when we look at the production cost of SAF, we can then move to the right where we can say we would use a discounted anhydrous, still dry ethanol coming from Brazil, where that could end up impacting the production cost by 6%, discounting the production cost by 6%. If we then use hydrous or wet ethanol, which we would need to buy more of that ethanol for the production of 100 KT of SAF because of the water that's contained within that hydrous ethanol, but we can buy that ethanol at a discounted cost, it will actually decrease our production costs by another 3%. So this is the advantage of the jet-enol process, is that it can take any type of ethanol feedstock containing any amount of water, which if you can buy at a discounted price can ultimately lead to lower production costs. This is all drawn here also to compare that even if you were able to build the alcohol-to-jet facility at a 10% less capex, that 10% less capex would only have a 3% impact on your production costs. This is to illustrate that really the highest impact on production costs is associated to your ethanol feedstock cost. As one further point of comparison, we've drawn here the cost of second generation ethanol because it does come at a much higher cost than first generation ethanol. You can see that it would increase the production cost of SAF by approximately 140%. This is to drive the notion that for a second generation ethanol being used to produce SAF via the alcohol-to-jet pathway, there may be lower carbon intensity coming from that, but that lower carbon intensity needs to be valued and needs to be paid for at a higher cost than first generation ethanol. So this is what we need to have in mind, is that not all SAF will be the same as any other SAF, and there needs to be a carbon intensity mechanism associated with it to make this a viable feedstock source for ethanol, for SAF production via the ethanol-to-jet pathway. So in conclusion, this is just to show that Axens, as a technology licensor, we have many solutions that can be used for the production of SAF, coming from our rich experience on refining and petrochemicals and our R&D through our mother company, IFPN. Of course, we can partner with our licensees to bring those de-risk technologies, bring a bankable technology that will lead to a positive FID. And of course, also we're there as a unique partner to help our customers study all the potential opportunities for SAF production from the conceptual stage, and then really working through the project all the way through successful completion and startup of the operating facility. So happy to engage at any point in time on any potential project that could be of interest, or feedstock that could be of interest for SAF production.
Thanks, Jeff, for really breaking down the different technology pathways with a bit deeper focus on jet-enol. I think we have a poll right here, and we're probably in the right direction. I think the audiences believe ethanol-to-jet will be the next major pathway. But really, I guess there's some questions already, a bit technical, but let's do the first one. Can the future processes be also used for biogenic fraction for household waste as a feedstock for ethanol?
This is a very good question.
Out of the box. Yeah.
Okay, there's probably two answers I would say for this question. The first would be, what would probably be mostly concerning is the consistency of that household waste and how you ensure some homogeneity to the feedstock. The Futurall technology is actually very, very flexible in terms of woody biomass-based feedstocks. It can be designed for a wide range of feedstocks, but we would not co-process those feedstocks at the same time. We would actually go through campaigns with those different feedstocks, but again, the facility would be designed for it. The reason, again, we do need to have during the normal operation, we need a relatively consistent feedstock coming in, because the enzymes and yeast themselves are live creatures. So they're going to actually be grown in situ in our process based on that feedstock. They're going to become familiar or healthy based on that feedstock. So if you're constantly changing the makeup of that feedstock, it would limit the capabilities to grow the enzymes and yeast in situ. The second piece to it would be, what is the hemicellulose and cellulose content of that household waste? So that would be a question of whether or not the feedstock would be a good candidate for accessing those cellulose components, doing the enzymatic conversion, and then finally the fermentation of those sugars. So that's what would have to be considered in this. I'd like to say any feedstock's a good feedstock, but somewhat consistent in operating, but also the sugar content is important.
We're getting there. We're getting there with the municipal solid waste type of challenges, right? Yeah, I think governments, or at least the ones we've spoken to, I think they realize the potential, except I guess the easy way out is to incinerate the bad stuff, because there's a lot of contamination and not so much recycling or sorting out of, let's say, the plastics from organic waste. That's the current limitation. I don't think it's like technology.
Yeah, and that would be I think that would probably be the biggest question is for this waste, municipal solid waste, organic biogenic waste from household, is it a better candidate for gasification? Obviously, most people in the industry know the story of Fulcrum, but there's been a lot of, I would say, gasification technology developments, a lot of robustness with the design that can handle municipal solid waste through the gasification process. Once you've done gasification, of course, you can look at Fischer-Tropsch pathway. But then another opportunity could be for gasification, producing a syngas that can then be used for gas fermentation to ultimately produce ethanol that can go into the ethanol-to-jet pathway.
All right, Jeff, I think that's another quite important question, right? What are the challenges in SAF and building projects making them come online, right?
Yeah.
Yeah.
Okay. This is a very broad question, of course.
Pretty broad. Yeah.
Yeah, I think first you can obviously get into the government policy mandates, incentive support that's required. There needs to be something that is driving the adoption of SAF versus fossil jet fuel to really justify FID. Now, I'm going to use this because Handel already gave a very nice presentation, and I would say if I was talking about this 3 months ago, it would be the very standalone, isolated conversation of, SAF is going to cost 3 to 5 times more than fossil jet fuel. Is that the case today? No, not necessarily. How long will that stay? Will it be something that we come back to in recurring years and decades? So the fuel security aspect of this is very important. And I think that is helping in many countries, as was alluded to. It's helping drive the discussion on SAF mandates and policies incentives today. Further, I would also say, not just on SAF, but this also goes for whether it's distillate as well. Diesel and jet are at a high price today. So also talking about renewable diesel through the HEFA pathway or these other technology pathways will also be incentivized, I would say, because of the fuel security debate. So that's the mandate policy incentive piece of it. The next thing I would say is feedstock allocation. So yes, we do see renewable oils and fats, especially UCO, coming under limited supply. Making sure that you aggregate enough of that feedstock at a good price point for the long term is important to make a positive FID on a project. When you get into the biomass project, I would say, again, it's feedstock. Feedstock is available, no doubt. The feedstock is there, but we've not seen enough work done in terms of aggregation of that biomass feedstock to bring it all together to really justify large capex investments on those biomass pathways to SAF. So that's also going to have to come. Final point, I would say, again, I alluded to this, not all SAF is going to be the same as other SAF. They're going to have carbon intensity scores with this. Today, we're in an infant state where it's HEFA SAF, and that's the price point. But the price point should not remain the same for lower carbon intensity SAFs that are produced either the biomass pathways or eSAF pathway.
Yeah, I think that's a great segue into carbon intensities. That's another question here.
Yeah.
Do we have to, what the scores for each technology? I think some are quite well known, like HEFA. Do we have to take default IQ values? So I don't know if Haldane also looked at this before, but that seems to be a roadblock. whereas HEFA is so low, right, in terms of the CI scores, right?
Yeah, I mean UCO is
At
right.
least UCO, right? At least
Yeah,
UCO.
so
Yeah.
waste-based feedstocks are again, but limited supply, and the price is going to go up. So, my opinion is on this is that the process itself is relatively a low. I mean, in any of the technology pathways, when we look at the actual processing of the feedstock into SAF, it's actually a relatively low contribution to the CI of the SAF. Of course, we design our processes with energy efficiency, high yields, et cetera. So that's what leads to that. But again, the carbon intensity of the feedstock itself is really what's driving that. And unfortunately, I don't have a good answer whether ICAO values are going to be because I think countries are going to have to decide, is that what their policy or is based upon, or are they going to do something different that is really promoting feedstocks on some scientific basis that they have locally within that region? My personal opinion is we need to be science-based, right? And we need to not fudge the numbers, but everything needs to be very practical, science-based, and not, I would prefer, again, this is very, what do you want to say? This is naive on my part to say this, but not influenced by lobbyists of certain feedstock choices versus the others. And I know that's very naive because that is there.
That's true. I maybe come in on that point as well. In just like a SAFA, I'm technology agnostic or pathway agnostic, as long as it meets sustainability criteria that's set by science. And at the moment, we have a fairly good system in place at ICAO to do that. It's obviously got its downsides in the fact that it's a little bit cumbersome. It's a bureaucracy in some ways, but actually it does send a good standard at a global level, and it's adaptable. And so if new technologies come along, or if new studies and new research comes along on the way that certain pathways are operating when it comes to carbon intensity scores, that can be altered, but it's based on science. And that is a really important bedrock for how we should think about this.
Yeah.
Yeah, I think from us, Fabrice was there last week as well. Thailand's putting like their own LCA methodology, and they're really putting a lot of efforts to really compute their, again, ethanol pathways to SAF, for example, and that's been submitted to ICAO, right? So the revisions can be made, right, at the country level. I think that supports really established biofuels producers, just like Thailand.
Yeah. But we also have to remember that we live in a global world, and we are a very global industry, and that just because something fits a sort of national priority, other airlines fly into those countries and have to use that product, and have their own pressures back at home as well. And so we can't just think about isolated cases from a national perspective. We also have to think about the acceptability of that discussion at a global level to your customers, which come from everywhere in the world, not just from your own local catchment, if you like. So that's a really important part of the process, thinking about the environmental groups that might impact you or protest against you if you're using feedstocks that maybe aren't quite as palatable to other parts of the world. And so it needs to be science-based because of that sort of pressure that can come from everywhere.
Yeah. Again, I think we're having quite honest discussions with various stakeholders, policymakers, to, I guess, find a sustainable way to really utilize feedstocks without jeopardizing further deforestation, for example, right? And again, balance smallholders who actually benefit quite a bit from additional revenues from the feedstocks or new crops, right? Okay, I think there are really a lot of burning questions. We probably want to take them offline, but any last words from the speakers, experts here?
No, I'm happy to. Yeah, I mean, I'm happy to take some. I see the remaining two questions. I'm happy to take those offline, so people can look me up, send me a LinkedIn, or get my email address. Happy to take those offline and discuss those questions. I see the two. I'm happy to target those.
Yeah, and listen, I'm just thankful that we've got such a passionate group of people looking at this. When we first started talking about it wasn't even called SAF back then. It was aviation
biojet.
Back in 2008, 2009. Just the education that we had to do to tell people what the opportunities might be. that's not really a discussion we need to have these days. There's so much activity going on, which is really great. We just need to make sure that we're doing it in the right way. So, science-based, we are thinking about sustainability first, but let's get this started as fast as possible in as many different places as possible because we need it.
Yeah.
All right, awesome. That's quite a day, and thank you everyone for your time and attention today. See you at the next webinar. Thank you.
Thank you, everybody.
Bye.
Thanks, Gabriel.
Thank you.
Thanks, Rory.
Thank you all. Take care. Take care. Thank you, Jeff. Thank you, Haldane.